Oh, sound. Somebody sound check me. Anybody say anything? I got no sound yet. Somebody say something.
Hey,
There you were.
something.
Perfect. Perfect. All right.
Are you already recording? It said.
I thought I shut it off. No, I did not. Very. And hey, this is Coffee Compiler Club. We're here today to talk about programming languages and compilers and language implementations and runtimes and typing theories and designs of programming languages and why everyone loves or hates their favorite language. And I'm going to let Alan here in a minute present Stroscot. He has a ton of interesting looking slides, and we will probably share them in a second here. Yeah, all been recorded live. Will show up on YouTube in a couple hours, however long I get to it. And that's it. So Alan, are you like ready to go, or should I put slides up now?
Well, yeah, I've got the slides on my screen. You have to let me screen share though.
Okay, well, that was the question, because I can screen share directly, but I can just say screen share. Go for it.
Yeah. So let's see if it works.
Right. And then yeah, the link to the slides is in the invite, and it probably should show up in the documentation.
Okay. Can you see my slides? Yeah.
I can.
Okay, and you can hear me talking? All right.
Yeah, no, it's freaking article.
Okay. Yeah, so this is a presentation on the Stroscot programming language, and I'm Alan Gardner. So this is yeah, so I also use the alias method 3 and 4. That's all my GitHub and stuff. And I took a picture of my desk because I figure people want to know what my desk looks like. It's really messy. I don't know.
You have dead trees next to your awards.
Yes, yes. So the talk outline. I asked ChatGPT for what a 45-minute talk should be, and it gave me an outline. And this basically follows it. So there's the history, there's goals, there's core concepts, there's my plans, and then questions. It's kind of a long presentation, so I think people write them in the doc. I made like a little area in the doc for writing questions.
About the people will be asking on the fly, and they hopefully they'll make it in the doc at some point, but I'm certain they'll be asking on the fly.
I figure questions are a better starting point for discussion than a slide. So yeah, like, is Google supporting it? The answer is no. I can answer that question right away because I put it.
All right.
So history. So my first language was Java, and then I found Haskell, and I was like, oh, this is a better language. Are there any better ones? And so I made this blog, In Search of the Ultimate Programming. And I was like, I want to find the ultimate programming language. And well, long story short, I didn't find it. I was like, okay, I'll have to create it myself. And like, so 2010, I was like, I'll do this. And then like, life happened and I didn't do anything. So, but then like, I was like, oh, there's Linux, that's interesting. And there's Nix and there's build systems. And this is actually an incremental language for writing, or programming language for writing incremental computation. And it was written in Rust. And I was like, Rust is terrible. And so eventually I was like, okay, I need a new programming language. And so 2018, I made
you can skip more history here.
Yes, well, that's it. Is I made the GitHub repository. I mean, everything else you can just look at the Git history.
Okay.
So what is the ultimate programming language? So I said there's the shackles of languages past, and so you want to ignore them and make the 100-year language. And so this is Paul Graham's thing. He made this thing called the ARC programming language, which is the Lisp language. And I was like, okay, that's interesting. But really what I want is like the awesome ultimate showdown language. You just kill all the other languages in a match of wits. Or
I think you're not ready to kill COBOL yet.
Yeah. And so practically I ended up with 4 goals. So first is functionality. It's got to be the best language. And so this is a picture of the largest Swiss Army knife in the world. And the issue is that it's too heavy because you can't carry it around with you. So I was like, okay, well, the solution is to get a minimal core. So you make like this tiny thing that's the compiler, and then everything else is a library. And then it just works because you pick and choose the libraries you want, and you only use the ones you need. But then it has to be learnable. And
All right,
so,
but we can read all this.
yes.
I'm
Okay.
helping you with your presentation.
And then there's concision, which is so on to paradigms. I made this map of all the paradigms on Wikipedia, and the conclusion was you need functions. That's the only paradigm you really need.
Okay.
And everything else you can implement as a library. But it turns out functions are not self-contained. You need like this little core subset. And so it turns out the core paradigm is functional logic programming. And, so there's like this one paragraph on Wikipedia, and it's like Curry and Mercury are the languages. And so I was like, okay. And I found 2 more after some looking. And, but the problem is none of them have term rewriting. And so I was like, all of these I need a term rewriting functional logic programming language. And that was a mouthful. So I tried like some other words, but, Maori, which is just
So why term rewriting? Why is that so make or break for you?
well, because term rewriting it subsumes functional programming. So like you don't need functions if you have term rewriting, at least in theory. So I have an explanation of term rewriting. Okay. So
Wait, we can read Wikipedia just as well as you can.
Yeah, so you have a rule. Okay. So like this is an example of a term rewriting system. So you have, 1 times x is rewritten to x. And then down here is an example of a computation. You have a inverse times a, and you apply the rule.
Is that Stroscot?
No, this is, well, I mean, you can write this easily in Stroscot because it has term rewriting, but the notation is math notation. It's not Stroscot.
So the core guts of the people optimizers are graph rewrite rules, which are very similar in philosophy to term rewriting.
Yes, they're very similar. So a term, I should define a term. So it's like a Lisp thing. So you have an atom, and
Okay.
then you have.
May I suggest that you probably don't want to try to explain term rewriting in this video right here and now?
Okay, fine. I have I should mention I have notes. So like all of these slides have notes which explain in even more copious detail than I'm explaining now the slide contents. So I'm skipping through this, but just pay attention to what the slides say afterwards, and you'll figure it out. So yeah, so all these features, you could do all sorts of things with term rewriting, and I figured out how to implement all of them. And you probably don't care about them. So the main thing, it does introduce non-determinism. So like you can rewrite something to multiple different values. And so that's the big issue, is how you handle non-determinism. And the answer is matching. You assign like names to each clause, and then you say, this clause has greater priority than this clause. And then it says, okay, I'll pick the answers from the higher priority clause.
What about just claiming there's one final unique form in the end?
Well, I mean, then you don't need the priorities. You just write the clauses without the priorities.
This is like the Church-Rosser one-step property.
Yeah, it's called confluence. Is that
confluence?
Yes. Writes a unique value.
Yes, I am trying very hard to get confluence in my core optimizer. But I would have suggested if term rewriting is your main language theory, you would go for confluence as opposed to going for picking one of the multiple choices as the best.
Well, so that's the thing. It's like, say you have like a slow version and a fast version of a function, okay? So you don't want to go through all the effort of proving that the slow version is the same thing as the fast version. So instead, you just say that the fast version has higher priority, and then it gets used. So
Wow. I guess I'm not. I don't think it's important either. I'm not following, but I don't think it's important either.
okay,
I still think
and then I was thinking about automatic specificity, which is I don't know.
I think
I
you're
feel
well
like
into the weeds at this point, sir.
yes. And then there's like all this other stuff.
This meeting is being recorded.
Oh,
Oh,
okay.
somebody got an echo going. That's fine. Levo,
All
your
right.
second appearance. There you go. He muted. It's fine.
Yeah, so the real reason I have method priorities is because I want to be able to call the method of the next lower priority, like the common Lisp object system. And so it has all these different kinds of methods, around methods, before methods, after methods. And then I figured out a way to make them non-deterministic too, so that you can call multiple methods and they get combined magically. And then it turns out if you do that, you don't actually need any of the other methods. You just need method combination and priority. So, okay, moving on. Safety.
All right.
Yeah, so Linus Torvalds was like, I love static checking, and then he, allowed Rust in the compiler. And so they're like 4 properties that they know how to verify, basically. They're assertions, termination, dead code, data races. The data races they aren't really that good at yet, but they can do some things. And it works. Like here's an example from like some university class that, they type in this program and it asserts 0 less than I, and you run it and it says verification successful. And that means it worked. Okay.
Yeah, that doesn't say a whole lot though, because the usual story with any of those verifiers is they immediately fail to prove anything interesting.
Well, so that's the question is, do they work? And I'm assuming for purposes of designing Stroscot that they work perfectly and have no issues whatsoever.
But that's pretty much known to be false.
Well,
they simply can't prove most interesting things.
So, okay, so yeah, so sets, because I don't have types. I never say the word type anymore because it just means too many different things. But you can assert that a value is a member of a set.
Yeah.
And Stroscot has this custom set theory. You just write a predicate and it automatically turns into a set. So you have the universal set, you have the set of all sets that contain themselves, and then there's termination checking so you don't run into problems with the set of all sets that do not contain themselves, which is Russell's paradox. It is like this well-known issue with naive set theory.
Right. When you say you have them, what do you mean?
Well, I mean, you could write them in the language. I've defined syntax for it. I haven't implemented any. What's the
asymptotic execution time for any of these? I would have thought that some of these things you're specifying here simply do not terminate themselves.
Well, the termination checking, you would specify a timeout. Like it has 15 seconds to prove that it terminates or it doesn't. And then if it doesn't work, you say, oh, it doesn't terminate and give an error message.
So the language spec depends on the speed of my processor?
Yeah, pretty much. I mean, it's like, compile. The language. No. See, that's the thing about mathematical properties. They're always true or false, but proving that they're true or false requires a certain amount of computation.
Sometimes that's an infinite amount of computation.
Well, yeah.
No, what he's saying is it's never an infinite amount of computation because he leverages the power of impatience.
Excellent word there. Okay. Yeah. And Aaron's asking, how do you compare this to like Prolog or Datalog?
Well, I haven't.
They don't have the power of impatience.
Oh, I used Prolog before. I would claim that I had the power of patience.
There's like logic programming is another few slides. So I'm covering sets right now. So you can have.
But sets are logic programming. Fine. Carry on.
You define a set, and then you could add elements to the set, So like you just specify it by enumerating cases, and you can take unions of sets and intersections of sets, and you can also define sets that contain everything and then remove things from them.
Yep.
And then there's partially ordered sets.
There's a challenge though if you allow things to be added and removed from sets, which is there's an assumption there that a set is mutable. And I know you don't have types because you crossed it out in the title, but there's a
it's mathematical sets. I think he's talking about everything's a new set.
Yeah,
immutable and all new sets.
When he says add 1 to A, though, he's not saying B is A plus 1. He's saying that A is A plus 1.
Yeah, and the old A lives on.
No,
and there's a new A.
What it is it collect. I mean, originally I had 1 is an element of A, like it was just a declarative sort of syntax. But I figured you wouldn't understand that, so I was like, oh, I'll make it add 1. So I don't know. So
but
like it's
you intend that
it collects all the definitions of things that are in A, and it says, okay, A is the set of those things.
Well, okay, so the question is, are you looking at, if I have a series of these adds here, are we talking about an imperative style or an explicit definition style? Is there a series of elements of A that over time keep having new guys and the same A notion? Or are you more like closure where you have an infinitely new things mathematically, and the old things live on in case somebody's referring to the old thing already?
Well, okay, so that gets into the module system. So like there's a fixed point of modules.
It has nothing to do with modules, I don't think.
So like literally all the definitions are collected by the module system into one block of definitions. And so there's only one definition of A in the program, and it's the fixed point of all the addition.
Okay, that's interesting. But it's declarative and not imperative.
Right.
Okay.
I mean, like technically it kind of is, because like each module is like a function that adds an element to A, and then it's combining those functions when it computes the fixed point. But the fixed point of adding an element to a set is just that the set has that element. It's item.
But that's a declarative property or definition style.
All right. So yeah. So exceptions. Well, you just have an exception set. So then that's easy. Really easy, right? Now that you've defined sets, you might as well use it for something. And so they have special handling. In the compiler, they automatically propagate. And so like if you apply f of an expression and the expression is an exception, then it evaluates to the exception. And you don't go into the body of the function unless it's a non-strict function, in which case it actually does go into the body of the function. But I won't get into how it actually works. And so every exception is recoverable. You just catch it. Catching assertion failures is probably bad practice. Catching segmentation faults, also probably bad practice.
So you're converting hardware segmentations into some notion of an exception?
Yes. So segmentation faults end up being exceptions. They just they get caught. The signal gets caught and it gets re-injected into the program at the point where it was asking for something.
How is it possible to have a segmentation fault?
I'm getting to that. And there's no special syntax. And you can
wait, no special syntax for segmentation fault, or
no for matching on exceptions. So you just say divide by 0 in your case.
We're getting there.
Yeah,
Lego was asking the obvious question Cameron just asked.
We're getting there. Okay, and lastly, I wanted to talk about function signatures.
We skipped over segmentation faults in a big way.
I'm getting there.
Okay.
So like a square function, we just define multiple signatures, and the compiler checks those signatures. and it doesn't change anything about the semantics of the function. You know, you can still
Earlier in the slides, you say that you don't have types. So this is type signature or set
well,
signature?
they
or-
look like type signatures, but they're assertions. I mean, like semantically, this is an assert statement.
Mhm.
Well, no, the question is, earlier you said, I'm never going to use types. I'm going to use
Assert,
sets.
hold on. This is something specific. Assert when? At compile time or
Yeah.
at runtime?
So the way this works, this asserts that if you apply square to an integer, then it will return another integer. And so the compiler statically checks.
What
that
is the proof that is an integer? So how does it prove that is an integer at compile time?
No. So you're thinking types. He doesn't have types. He has sets.
Okay, how do you prove that
So-
the
So
result is
all
an
he has to
element of the
prove
set?
is that if he has a
me
value
know
from the
that.
set that
So
goes
like
in,
here.
and the set is called int, that when it comes out, that the
Yeah,
the
the
value is
multiply
also
primitive
Is also
preserves-
element of the set. Oh, great! How can I prove that the integers are a bounded set? I mean, to
Well,
not
like,
include the whole
look at
program for if
example
you,
bit. Okay, it has an integer x, and
that's fine.
okay, and it has an integer I, and it
That's
asserts
also fine.
that I is non-negative. And so
No.
if you have a set of non-negative integers, you could
Mm-hmm.
literally write int to non-negative integers, and that would, and then the
So
prover
the
follow the
integer is unbounded. It's not 32-bit, for example. It's
When
No,
you
no,
say-
it's a C integer, so it's whatever the machine type is.
Okay, so hang on. What the I guess the question here is that if capital INT is the set of machine integers, so it's 32-bit, and I add 1, do I get a member of that set?
Oh, well, okay, so maybe I should have written like or exception after it. I was just assuming it would wrap or something.
Well,
so.
you can assume whatever you want, including wrap, which is what C does. But you've also said, I have a set of ints and you're not specifying what they are. You've changed now it's set of machine integers. I don't have types, they're just sets. So I'm assuming it's the set of, you said 32, so 32-bit machine integers. Okay, that's a 4 billion element set, it's totally fine.
So what prevents the program to include anything in that set that is called an integer? So all the term belong to that set. What prevents that? What
You can use
categorizes
anything
the
you
values?
want. I mean, like that. I mean, it's a general purpose verification system. So whatever set you write, it will check that properties of that set are true.
So
Well,
what's the properties of the set of the integers? So they are non-negative. That is the only
No,
thing.
he said machine integers, the plus and minus. You could make another set, which was just the non-negative integers. And then somebody has to go prove that if you add 1 to a positive integer, you get a positive integer, which will fail if you wrap.
Okay. I'm trying to grasp what
Oh yeah.
what the whole
I think
concept of the
you're a
types
little
as
all over the map here, Alan, which is
Mhm.
fine. I kind of expected that, but this is what the point is to help you focus on some.
okay.
Yeah. So
And the other thing I was going to say is that all your operators have to have some sort of definition that says if I'm given something in the integers, I get something out of the integers or floats or whatever.
yeah, and that's what this signature says.
Right, but now is the one another question Tito asked, I'm asking too, is this is statically shown. You're not going to run this dynamic test where you confirm at the end that you got the right
Yeah.
answer.
No, well, this is an assertion, so it's checked to compile time.
It's a compile time test. Yeah, okay. Fine.
So okay, but it's here is a problem, because if it's a literal, you can probably bound it to check it if it's overflow or something. But if it's a square x, how do you know what x is, and how do you check its properties?
Yeah.
Well, that's why you have the function signature. It tells you what you're checking. You're checking integers, you're checking floats, you're checking complex.
And if I
yeah.
have
So
something
conceptually, Tidor, X is every member of that set going
what?
in.
Okay, that's
it's one
probably
of those
fine.
3. Like
It
if I accidentally apply square to a dog,
No.
somebody has to come along and say it's not an int, it's not a float, it's not a complex.
I'm assuming that it can belong to the int to int set, to the float to float set, and complex to complex set altogether.
Yeah. I mean,
Yeah,
if you're doing
Alan,
probably
is
more
that correct?
Like
type
a
theory.
multiplication operation.
Okay, okay. That's fine. Okay. When I have questions, I will ask them, not to
Okay.
interrupt.
So, okay, so then the other type of signature is a restriction signature. And so that, like, it uses this kind of pattern matching syntax. And then you say that, like, it's a member of the type, and you give it as part of the argument definition. And that translates to a conditional.
Yeah,
on
it's element of, right, that's a runtime test version.
But
Yeah,
yeah,
and that's runtime test. And
Yeah.
so it's runtime dispatch, runtime overloading.
What happens for members who are none of the above?
Well, then it doesn't match, and it gives you no reduction error.
A runtime error.
Yeah.
Okay, well, fine.
Yeah, and there's also this thing called return type overloading. So I don't know. It does work. Like, you can define it. So the idea is you just define like everything as a non-deterministic function. So like reading a string returns every type of thing that can parse that validly. And then you say you want the integer version. And I looked at actual usage of that, and it was like nobody ever wanted that. So the answer is you just write the type in as an argument.
Yeah.
But it does work. I mean, like I mean, it's in the semantics of Stroscot. It's just
I
that
looked
I don't
at
think people want to
return
use.
type pattern matching in AA and decided that it would make too confusing as to the rules of when it would or wouldn't work, and no one really wanted it because of the confusion of understanding why something typed or why something didn't. But the
Yeah.
actual implementation of my pattern match for overloads can totally do return type overloading matching. It's not a problem.
Right, and the non-deterministic semantics can do it too. It's just it's not something I think people want. So
Yeah, okay.
I don't know. Well,
It's
I mean,
a
maybe
pattern that's
someone
used
will go
fairly
on-
often in Rust. People will put a dot into at the end of something to try and coerce it into whatever the left-hand side wants.
Oh god,
Yeah.
really?
Yeah, but
Okay.
you look at that syntax.
But you
and
you
they-
have to ask if you want to dispatch based on the other side. You have to put a dot into at the
Okay.
end.
Well, I could add it as an optional syntax too. I would think that you'd actually not want that, but fine, I don't know. I can't ever tell what people want. All right, carry on.
Yes. So then there's input output. So it's based on continuations. So like you write a program and it evaluates to a value with callbacks. And it's like if you wrote really explicit JavaScript callback code with like, a function for every callback.
Haskell monads here. This is like
It's
smells
not
like
a
a
monad, it's a continuation or a callback. So like you read a number and then you compare the number with one and then you print you got it or wrong and then exit. And so then there's unsafe perform IO. So that's like if you want to do something IO, but you're in the middle of a pure computation, it bubbles up. Like addition is pure, but you want to print the argument first. And that's useful for a lot of things, like Haskell uses it all the time. And it's called unsafe because it's non-deterministic. And so I should explain like that there are two rules for resolving non-deterministic. So one is that non-exceptions are preferred to exceptions. So if you have something that gives an error and you have something that returns the value, then you get the value back. The exception just gets ignored. And the second rule is that at most one exception is returned, and that exception is the compiler's choice. And the reason it's the compiler's choice is because if you have multiple errors or exceptions that are possible, then usually you don't actually care which one is returned. So like if you have 2 division by zeros, then like you just want a division by 0 error. You don't care which one it actually gets reported. And then there's top level has to be deterministic. So if you call print and you can print a 1 or a 2 and you don't know which, then it's an error. You can only do one thing. If your program is ambiguous and you try to do something, you're like, it says, I don't know what to do. You have to decide. And then function signatures also enforce that it's deterministic. So like if you write your int to int type signature, then it can't be non-deterministic.
So remind us again what LUB is.
Let's see, that was back.
Least upper bound.
I would say least upper bounds. What I was
Just
going.
a shorthand for non-deterministic choice.
Yeah.
So, I mean, I don't know. So there's actually a whole semantics behind least upper bound that's not quite non-deterministic choice, but for purposes of this talk, it's non-deterministic choice.
Oh, in the land of AA, I do lattices. Least upper bounds are basically the meets or the joins of your lattice elements. But I don't ever talk about it in terms of language spec. It just flows out of the implementation. Fine.
Yeah. Okay. So finally we get to logic.
Lucky you.
Now go back a second. Go back a second.
Okay. All right. So what?
All right. Yeah, fine. I was thinking through
I
the
mean,
land of H2O, which is not anything to do with you. I certainly get multiple unrelated exceptions, and I have to pick some set, and I have some rules on how.
That was my question. That was exactly my question. What would happen if you return if you have multiple exceptions that are not of the same kind? How would you pick what exception?
Well, so I told you it's the compiler's choice.
Yeah.
So the compiler picks whatever
Okay.
exception it likes, and then that's what it gets.
It will pick the last exception happened. Okay, fine.
Yeah.
Yeah.
In H2O,
Well-
it's all concurrent. You get the first one wins per se, except I get millions of them. So then we'd start to count identical ones, and we'd keep the set of 3 or 4 top ones and their counts. And in the end, I'd throw a blob, which was, I got 4 different exceptions, of which I had 100 million of the first kind and 10 of the second and 100 of the third.
Okay.
And here's the stack trace and
To
the,
go back one
debugger
slide, Alan.
sends you to
Okay.
it.
So halfway down the div by zero example, I mean, most languages that I've worked with, you don't have 2 exceptions there because there's a definite order of operations defined at the language level, at the specification level. So therefore, you can't get to the second exception because the first one occurs. So the plus is at the root of the AST for that expression, and it's left leaning, so it goes to the division that's on its left, which is 1 on its left and 0 on its right, and that's where the exception occurs. So why is it
That'll cost you
possible-
some parallel execution if you define that, though.
Oh, well,
Yeah.
parallel execution would cost you a fuck ton here. Why would you do that in parallel? Like,
Conceptually,
no,
imagine large, complicated things on the left and the right. But if you throw, and you want to run them in parallel, but if they each throw, you're going to pick one of the exceptions at random.
so I must have missed the part where this was all being designed to be run in parallel.
Oh, well, that was where I skipped over term rewriting. So like the whole way term rewriting works is you just apply rewrite rules in any random order, and then you collect all possible results at the end. That's where the non-determinism comes in.
So
That's what
he
made me
didn't
think of
say
data log.
there is that semantically, it's as if you executed all things more or less in parallel, step by step, as much parallel, maximally parallel as possible. And if it bottomed out into an answer that was one answer, you win. And if it didn't, you got a bunch of answers because everyone ran parallel in different directions. And so how do you bring it back being deterministic from non-deterministic parallelism? It's parallelism at the semantic level, at the tiny micro op level, if you like. Turning that to efficiency is different, like getting an efficient solution out. But semantically, go in any order. So in AA, when I do my typing analysis, I have a big old work list. I can do it in any order. I could do it in parallel. Way too much efficiency loss to do it in parallel, but I do it in any order, and I change my random seeds for debugging purposes and try different orders.
Right.
And I
And so,
assert on myself if I fail to get to the same answer in the end. So I get where he's headed here. This is
right. And so like, I mean, a big property you want to prove is confluence, which is that it doesn't matter what order you do it.
right. And I'm
And
trying
that
to prove
would
confluence.
either say, okay, I can pick the best order, the fastest order, right?
Right.
But if you don't have that, you just execute all of the rules in random orders until you get all the possible results.
Yeah, I don't care which order I get as long as I get to the
Yeah.
same confluent answer.
But if you have finite precision floating points, you're going to have some fun there.
Yeah.
Oh,
Right.
yeah.
I'm not doing
So
floating
like,
point.
I mean, the
I'm not doing
floating
floating point constant
operators
math and typing
probably.
system except in a deterministic order. But that's a thing for Alan. Yeah.
I mean, like the floating point, it doesn't matter what order you evaluate it in because you're just
not
binary operations.
in pure math. You're correct. In computer math, you're wrong. IEEE 754 is not associative.
Well, yeah, no, but like you don't have an associative rewrite rule. You just have a floating point. I know how to add two numbers rule.
Right. But if you don't make it associative, then it doesn't matter. Yeah.
All right.
And in fact, that's a big ticket item for H2O. All things were done in the same order. Parallel were allowed, but all the math ops done in the exact same order. So it didn't matter what order your math was done. You got a bit for bit identical answer in the end. And that was a crucial feature, and you could do it efficient.
Yeah, so the logic programming stuff, I haven't really worked it out, but this is like an example I came up with. You just, you define your variables, you define what they're elements of, you say they're all different, and then you have the send more money problem.
This is like back to data log or Prolog again.
Yeah, and so this is, I mean, it doesn't look like Prolog, but it essentially is Prolog. I mean, got all the power of defining constraints and implications and stuff.
Yeah.
So, all right, on to memory management. So yeah, I used the picture of fire because I feel like memory is like fire, and if you play with fire, you'll get burned. I don't want people using references or pointers, but you have to have them anyway for performance and stuff. So pointers, they're low level. They have they're mainly for the foreign function interface, and they're numeric indices into an array of bits. So like you define 1, 2, 3, you can write some hex bits to it, you can read it, and you get some hex bits back if you're lucky. And if you're unlucky, you get a segmentation fault. So, what did you expect when you read a random address in memory? So, and then you can deallocate it, and that usually goes into the memory allocation. So, I mean, technically it's not really. It's actually separate from the pointer system, right?
Deallocate what?
Yeah,
right.
Exactly.
Deallocate the pointer or deallocate the thing that the pointer points to?
So what deallocation is it operates on the page level. You're telling the operating system, I don't want this page anymore. Please, remove it from my virtual memory space.
And how is that tied to the thing on the right where I said, make me a new ref?
Yeah, and so it's not connected at all because references are completely different.
Okay, when you say not connected at all,
I mean, they're similar.
I'm allowed to deallocate my own memory, and then try to do something.
Yeah, so management is manual. You have to deallocate the memory, and you have to deallocate the references if you're done with it.
Well, you said delete on the right and deallocate on the left. I'm trying to merge these two systems. Near as I can tell, the low-level system will just crush and break all security in the right high-level system. So
yeah, so references do not live in memory. So like you can't write to a reference with a pointer. They're separate spaces.
Okay, so hang on, right? So
spaces how? Virtual spaces or?
Yeah. You declared a C-like memory space for C-like languages FFI.
Yeah.
And you've declared a heap-like memory space for garbage collected / managed pointers.
Yes.
On the right-hand side. And you've declared these two are non-overlapping.
Yes. And so the way you do that is you just allocate, a big space for using references, and then you set the protection bits so that the pointers can't access it unless they do something special first. And then you only allow doing that special thing in your memory management.
And then you call off to your FFI for your audio codec or whatever, and he does what he does, but you're protecting your heap because pointers you hand off to the audio codec can't actually mutate the heap or something.
Yeah. So well no. So like you literally can't pass a reference to an FFI thing because it doesn't have a memory address. it has this weird symbolic thing that gets
Where does weird symbolic thing
Well,
actually-
right. So my high level language has loaded an audio file from disk. It's still in the high level heap space. I want to hand it to a low level codec that's going to play the music. How do I take my data set in the high level and move it to a low level memory space?
so you read it and you have a value, right? So
I
the
have
value,
a large value. It's many megabytes.
right? And
Okay.
it's like, and it's a structured value. And so what
Yes.
you do is you write a pack routine that walks over that value and converts it to bytes. And so then you get this large bit string. And then you write that bit string with the pointer API into the memory space. And then you pass that pointer to.
You have to copy it from one side to the other.
Right.
Okay.
And if the compiler is lucky, it can optimize it so it's actually
Right.
zero copy, because references don't live in memory anyway, so
Right,
it doesn't matter where the compiler stores.
Okay. I'm getting the gist of what you're trying to say here.
Yeah. And so but you still have to delete the reference once you're done with it. And so there's a way to not do that, which is to use a finalizer, and then you get deterministic deallocation. So you would just write a cleanup function.
May I suggest that a finalizer is a bad name for Java overloading terms?
Well, I looked at terms, and finalizer was the closest thing.
All right,
So,
fine.
yeah, you're welcome to suggest a better name. So
I mean, it's a thing that runs immediately prior to deallocation, right?
yeah, so no, so the way it works is you give it a deallocation function, and you keep calling use on it. And once you stop calling use, then it deallocates it.
How do you know? How does the program know that you've stopped calling use?
Well, so that's where the transformation comes in. So it literally walks the program structure, and it says for each point in the program, if it could call use, then I'll keep going. And if it couldn't call use, then I'll free it.
Okay, so you're trying to write some analysis code, which I can't interpret anytime soon. But basically, you're claiming there's some structure you can do that says, I understand the lifetime management here.
Yeah, it sounds like it holds a reference in the program. It calls something.
So if I make an array of 1,000 of these things, and I pick at random an element from the array using the random function, and I null it out, I would like it to finalize, but I have dupes all throughout my big array of the same thing. I make 100 things, I put the 100 things into 1,000 element array, but I dupe them each 10 times randomly throughout. So each of the 100 things are in there 10 times roughly, approximately. Then I start removing at random things and wiping them out with null. When do you deallocate?
When the last thing is removed from the array.
So how do I tell the last thing's been removed from the array?
Well,
do forever array element sub random of random choice is equal to null, and I do that forever. When do you know I got the last element out of anything out of that array?
Well, the answer is there's state. It keeps track of that state when it's working on the transformation.
What state are we talking here? The
state, the list of finalizers that are left in the program.
So they're all left in the program to begin with. I have my array full of everyone's used 10 times. I stomp a random element to null. Do you now count somebody's down to 9? Are you doing reference counting?
Well, no, I say, is anyone going to use this? And it says, oh, there are 9 references left, so it's definitely going to be used.
Okay, so every time I stomp a null in, you sweep the entire array and count. Yeah. I can rapidly turn this into infinitely expensive. Like you can't prove this in any reasonable way, and you can't, and the cost is astronomical at every step. Like I can make a heat death of the universe expensive here really quickly and unprovable both.
Array,
but it sounds like he's trying to promise soundness, not precision.
Yeah.
That it could look at and say, I'm just never going to free any of this stuff because I can't tell.
That's an acceptable answer. I'm trying to figure out where he's at on the spectrum here. It's okay to say, I can't figure it out. I'm never deleting, so I just leak. Okay.
So the next thing is an example of how this works. So maybe that'll help.
I think I have my counterexample ready, but we can look at your example.
Okay. So we have a main program and it opens a file, and while it's not an EOF, it reads the program and it calls some processing operation, and then it exits, okay?
Yeah.
And so the open, it opens the path, it gets the finalizer with the close operation, and then it has a mutable variable for false, or for that represents the EOF. And then it passes it around, and it
Okay, that's a sound provable thing because it waits for something that it knows when it happens, then we can deallocate. So that's fine if you model something finite.
right.
But if,
And so you just write. So when you convert it to callback style, it looks like this.
Right. But my issue is that I don't match your pattern here.
And it works, and then it inserts the close operation, and then you get this. This is what it looks like.
Right. I get you, and I'm just saying I have a different example where at no time can you prove analytically that any of the elements are dead, because the random number generator defeats you as to which element dies in what order, and you're forced to never free, which is okay, or reference count, or if my while not done stomp into null, you wait till the entire while loop and the lifetime of the containing array dies, and then the contained elements within it die with it. And I'm trying to figure out where your head is on that.
Okay, so all right, well, that's the end of the presentation. So I'll just like so let's go to the Google Doc and figure out how to let's see what your example is.
Okay, yeah, right. I'll just do here. I'll pick a slot here and write something stupid in it.
please share.
Yes, let me do that. But I'm going to write on the fly, so I'm just going to make mistakes. It's really boring to watch as I screw up over and over getting but the example should be easy here. Oh, here, so pet, 1,000 pets. And, we'll call this a init here. So I'm going to assign to a random element of A, either a new pet or some other random element of A, and do that a million times so that the array A is filled with many pets on average, maybe 10,000, 100,000 pets, but also many pets are duplicated and some slots in the array are null. And it's a giant higgledy-piggledy mess. And then I'm going to repeat again. I say million, but whatever. Now I'm going to wipe things out. And my question is, when do I start freeing pets? At what point can you tell that a pet is dead? And then to help you, I've made a finite loop, and it just returns me something stupid. I don't care what. I might count the number of live pets.
Yeah, I mean, I think you have to do something that uses the pets. Like if you insert a print.
Why do I have to do something here?
Because otherwise,
it'll lazy down to nothing.
Never allocate them.
Oh, okay. Yeah. I can keep you from lazy down to nothing here. Right, and print's one of them. So when I'm all done here, it's going to be if a sub, rand is not null, it's the same rand here. Then yeah, print A. We'll do this. Or rand is length of A. Right, something like that. So now he just prints the live ones. When do you free the dead ones?
So
this is a question for Levo, by the way, as well, who says he has memory management, and I want to know, this work?
I'm
Let me
tempted
try
to say that we track the pet reference when it use it in the allocated.
Well, yeah, so
That
what you just said was,
that-
hey, reference counting. And
Okay,
the
that's
final
fine.
answer.
That's fine. But if you hold if somewhere in the program hold a random element of the array and you hold for the element, you don't know which element it is. And
The
you are
reason I
forced
did
to
it this
leave the
way
program.
was to mimic having a large, complicated program where random elements are held onto by many folks from all over the place, and you can't really tell statically locally. There's no local analysis you could do. There's even no global analysis you can do to say I held onto or I didn't, without something else being thrown in as part of the requirement of the language spec. I have to say things about lifetimes. Well, you don't need to print here. Or I have to say something about they're all alive until I'm done using the array A, the pets array. So I said A here, but it's the pets array. And then as soon as the pets array dies, all the contained elements within it die, but I have to walk the million element pets array looking for which elements are alive and which are dead.
Yeah.
There's something going on here that you have to do more of to do a lifetime analysis.
Well, okay. Well, I'm trying to think. So the question is where the last point of use of the thing is. So,
The last use is the print at the bottom. The precise last use point is the print at the bottom for only those elements that live to there. Sometimes the last use is that pets of rand is equal to null, and some pet got wiped out to null. That's his last use. Sometimes the earlier pet stomp took a pet that had been down and randomly stomped it with a new pet, and the old pet that was there died, or he might have been copied to some other places and didn't die. So in each of the places where I assigned the pets of rand, I might delete the last use of some pet.
And different data structures exhibit different memory
Right.
behaviors, shall we say. So
Right.
a directed graph with cycles is, a fuck ton of trouble for doing lifetime analysis on, because you're I'm saying a mutable graph where you're adding nodes and adding connections and removing connection. Like how do you know when one of the nodes is reclaimable?
Right. And that now the usual story for efficiency is people get imprecise and they say, I'm just going to increase the lifetime to some larger time because I can't tell in the microscope. And the other way they do it is reference counting, which has some interesting overheads, or garbage collection, which has its own interesting overheads. So I'm trying to pin you down to, I can't compute this. It's not computable in any reasonable way. And I can make something that's infinitely not computable by adding a little more grief to, halting problem. Here you go. So it's not generally computable. Are you going to do garbage collection, reference counting, some sort of approximation on lexical scoping? It was like,
well, he's going to analyze it for 15 seconds at compile time and then tell you that it can't compile because he can't figure it out.
Yeah.
So
yeah.
The
Well,
power
that's
of
Rust.
impatience.
Yeah. It'll come along and say, I can't prove the borrow lifetime management, so I'm going to blow up on you at compile time. Yeah. Like, I'm okay with any of those answers. I'm just trying to get you to think about the problem.
Okay. So I'm writing what it does. Okay. So, all right. So, okay. So if you, the code block after, the code block you wrote, I added where the free calls go. So, so that's,
you're missing a free call in the first loop.
yeah.
Well, the whole point of this game is to confirm that it's actually really hard to find all these places.
Well, no. See, I don't need one in the first loop.
Yeah,
because the rand call could read any pet in the second loop. So, I mean, if you're saying like, I guess if you're saying if I have to, pets equals pets rand.
Yeah, if in the first loop I have filled in slot 500 with a pet, then after a while I overwrite 500 with a different pet. The first pet is dead and needs to be freed. So
Yeah.
you can totally require a free call in the first loop.
Yeah, okay, fine. So there's also a free call there. And so I guess the question is how you implement this check that there's no no pet in the array.
Yeah.
And like, I don't know. I mean, I mean there's several ways to do it. You can use ref counting, you can scan the array.
Okay. I'm coming around to what are your choices? Scanning the array can be made arbitrarily expensive as I turn from an array to an arbitrarily large, complicated program structure, which has a huge count of infinitely interconnected random crappy things, and you have to go check them all. And then the other one would be reference counting. And the other option you haven't said yay or nay on is be less precise and don't free right away. But get it later.
No. So that's the whole point of the finalizers is that they are precise. They're deterministic. So
Then probably you need reference counting. Hey, see you later, Arthur.
yeah, so the reference counting is probably, I mean, it's certainly useful to prove that it can't be.
People do it. Now, they won't catch cycles.
You can be deterministic, but you can also avoid reference counting. There's a version of ownership model. I mean, think of C++ container with an allocator. Think of this pets array as having a specific allocator tied to the scope you are in. If that array goes out of scope, then everything allocated but that allocator goes out of scope too, and all of the pets are dropped at once out of scope.
Yeah.
Specifically, I'm tying this to this scope guarded allocator because you do not want to do the standard library containers, which would be dropping this one by one by one by one because that's more expensive.
Right.
So instead, have a one allocator tied to your container, like in the PMR, the polymorphic allocators library, and just drop everything at once you leave the scope. It is approximation, but it is
escaped.
Of course.
It's a very common pattern for C programmers to make a custom allocator, use it for a while, and then drop everything and not reference count in the middle. But you need, I mean, if you want to do this properly, you need some compiler support that says, I'm using this allocator in the scope.
And by the way, value semantics are going to make a lot of things easier for once the escape analysis problem goes away. Because you are not going to have any escapes, you would have to copy them out explicitly as a separately lived distinct object. So that's why I would not use reference semantics in a language, by the way, because that would make a lot of memory management much harder.
Wait, not use reference semantics? I have a bunch of giant pet
vectors,
and I want to.
Because you would need, as Aaron just mentioned, you would need to do escape analysis because maybe you would be returning one of those pets, and if returning one of those pets means returning a reference to a pet, then you need to keep this pet alive.
Yes.
I don't want to solve that kind of problem.
Yeah.
So I would use value semantics just to avoid solving that problem.
Right. And the problem with value semantics, of course, is the expense rises rapidly as the size of the thing that you're referencing, you're copying.
Yes, sure, but there are solutions to that, like in the Swift or Valve programming language, when you can just move them out. You can implement.
When you reference something from the pet, it gets the ownership or it gets the linearity, it gets the pet itself, not a reference to the point of the arrays itself.
Yeah, that's transfer. That's ownership transfer.
Okay,
exactly. And you can implement ownership transfer by move, like Rust does, for example.
Okay.
So if the pet is 100 gigabytes, that doesn't matter because it's just gonna transfer a pointer to that pet, and you cannot refer to this pointer in the original scope, and because it has been transferred. So that's fine.
Okay.
Would you rather have to label your clonable stuff as a thing that you can copy, or would you rather label the stuff that might be big as unclonable?
Yeah.
I would call out the copy operation as the special case, because in my experience they are rare. In C++, you actually don't, even though it is a language with value semantics, you don't actually copy that often. Most of the classes in LLVM don't call the clone method because you don't need to. So I think copies, in my experience, are rare enough that I would call them out as the special case.
So that gets into like how you make a usable memory management system. And one of your options there is to say, the compiler wants to complain to you about your escaping somehow. So at the point where you say it's okay, that amounts to a copy. But the compiler should catch you, force you to choose copy or not.
For ownership transfer implemented by move, which
Yeah,
is
and
internally
ownership-
pointer reassignment and disallow the use of the pointer in the area scope.
Yeah, yeah. Food for thought.
I don't know. I mean, I don't really I mean, certainly doing a memory scan is expensive, but I don't think you could make it arbitrarily expensive.
Oh, certainly I can. I'll force you to memory scan the entire contents of your live memory set with arbitrarily complicated structure, so the cost per scan point is fairly high. And then I can say
we succeed in doing that with GC.
Yeah, but you
And-
can't make it arbitrarily
Like-
expensive. It's always limited to the set of allocated objects.
yes, which
Yeah.
can be as big as until I run out of memory.
But every
But an
gem,
Azul box didn't spend all of its time scanning the heap.
So
Well,
that's garbage
technically it did, actually.
collection.
It was always garbage collecting.
Yes, it was, but it burned CPUs that it had spare of to do that. No, actually, Cameron, they aimed for having idle time on the GC, but that's a garbage collection. And the point of garbage collection is in an efficient way to scan all things, because they don't try to get smart about structure other than just this word is a pointer or this word is not a pointer. Right, and then you have the garbage collection issues, which is non-deterministic pause times while you break and get a, collection happens, and memory issues, and it hides leaks until they run you out of memory, and then your GC times gradually get worse and worse and worse because you're forced to collect more and more often until you crash or out of memory. And there's a bunch of issues that are known with garbage collection. There are also a lot of really cool, good things that come out of garbage collection, and that mostly these kind of problems you can mindlessly ignore. Cost you 0 to check that all the pets are alive or dead, because at some later date, the garbage collector will count them exactly the hard way once in bulk over everybody and all things, all simultaneously, all in the background, and tell you what's alive or what's dead. So, there's some good shit for garbage collection here. I'm not saying yes or no. I'm just saying choices to be made. For things like, the new pets, replace new pet with new open file handle. And then you run out of open file handles because you're waiting for the garbage collector to go find that they're dead and close them. And that was a garbage collection fail for GC in general. The Azul collector had a different take on that one, which is we collected so fast that happened so quickly that people were shocked to discover that their things they just stuck in the hash table that were weak refs got deleted the clock cycle after they stuffed them in. And they hadn't yet made a strong ref to it, even though that was going to come one clock cycle later.
How much sense does it make to sort of do all three and be like, I'm tracking ownerships and lifetimes here, and for this pointer, I know it comes into scope here, I know it goes out of scope here.
Yeah,
I can do the whole thing very efficiently.
Yeah, and
But if I
more than-
can't, then I'm going to throw it in the reference counter. And
Yeah,
for the
there's
reference
more than
counted
3.
things, I'm going to have a garbage collector that periodically just is trying to detect the cycles, but is not doing most of the work because the reference counting is doing most of the work more cheaply.
Yeah, there's more than 3, and I love the idea. It's complicated, which is the reason why it's not done. But I've actually seen a few languages.
Oh yeah, I get that it's expensive
mixing.
in your VM developer time.
Right, exactly. But it's a cool idea because the compiler can actually analyze the code. And I think this is really what Alan is referring to in some sense at some level, which is he can look at the code and say, I have an answer for this.
right.
And the garbage collector is your end of the line, like I ran out of answers, so fuck it, I'll garbage collect, right? But
Right.
But
They're
as
your
long
memory
as-
manager of last resort.
Right.
as long as you reach 90% of the problem, then garbage collection of the 10% of the problem, it's more
At
than-
which point as a compiler or as runtime do you switch between reference counter and garbage collection, other cycles or anything else?
I think you can separate them in different zones, if you will. So
Well-
there is a garbage collected region, if you will.
Oh, you are talking about programmer manually annotating. I thought Aaron was proposing
no, don't do
automatic
that.
analysis.
No,
No,
not
automatic.
automatic.
So you can imagine there's a fallback the compiler hierarchy does without any annotations. But you could also imagine that there are times when I absolutely badly want to force that file close to happen deterministically, and I want to annotate to force correct behavior on that he's going to close the fucking file at a reasonable time.
I would
So when I
assume
do
that
try
when it-
finally in Java, that's me annotating that I'm closing the file when I exit the scope.
so why don't we do the inverse? The file closes when it goes out of scope until I say so doesn't close it. And
So
I
that would be
Well,
I'm
because then you
declared-
run out of file handles
yeah,
in
if you don't-
reality.
right. But
Which
wait,
Which
but
is
there's a
exactly why
thing.
Python needs its with statement. It
Okay,
says
wait, back
with
up.
open, meaning when this with block ends,
But you
the
can
thing
still,
that I
yeah.
with better go away.
So there's another way to do it though, and that's when you grab a file handle, the file handles on his type somehow says, I'm a thing that can only be done lexically scoped. So you fucking better prove lexical scoping on me.
yeah,
And it's
that's
not
fine.
in the code that's calling, give me a file handle. It's on the file handle's type somehow. And that goes back over to the code that's calling it, which now is burdened with, it must be able to prove lexical lifetime.
And that it's
And
if
there's no
it's
annotations on the user. The guy just says, hey, with open file, blah, 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 do yada, yada, yada. And then it promptly, because you said open, that came you a file type which said, I must have a lexical scope type. I mean, whatever. And this compiler must prove lexical scoping. Just like,
And that's not even necessarily a terrible API if you've got fs.open gives you a lexically scoped thing and fs.open for gseed.
yeah,
if
right.
You're
yes.
desperate.
Yes. And here I don't care about the thing. So just give it to me and it goes away when it goes away. You know, when the GC finalizes it. Yeah, right. Yeah. Yeah.
But you're going to look at that and it's going to be a code smell. And you're going to be like, why do you have fs.opengc
Because
here?
I can't
Do you
tell the
need
lifetime
that?
of blah, 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 which is a fair thing to maybe it's time to restructure. But right. But no, yeah, it's a code smell. I'm with you.
or go linear. So if you call fs.open, the linear with demands that you call fs.close. So if you don't close them, then
I think
compiler.
if I can prove that you must call close, I can also prove the points where your close should be called by and put reasonable closes in for you.
Okay, that's if you can calculate the scope when
No, I
and,
think as soon as you say you have to be some sort of scoped rule, some sort of lexical, whatever it is,
okay.
if I were to prove that you called close on every exit path, I already found all the exit paths and I know a close has to be there. So
You
I
know
can just
to
close in for
close.
you.
Yeah, when
Which is fine.
Now you might want to annotate, and here I'm closed, but the compiler has to know already. But if you annotate it, that's like a documentation saying, just for as a reading purposes. In fact, it's actually dead here, and the compiler already knows it. Maybe
maybe.
assert that I know the file is closed here. Assert that the type of the file object is the closed type. It's a session-y type. It has open, read, writes, close, whatever other things. And you can just assert that the type of the file descriptor is the closed file descriptor with a type annotation. But the compiler must know.
Well, so I wanted to say, so like the point of the finalizers is that they just define the semantics for when you want something closed, right? Like there's not, you don't have to decide, oh, I want to use lexical scope. Oh, I want to use reference.
Right.
Oh,
You said here's an action that means close.
yeah, you just say, here's the action that means close.
Yeah.
And it turns out if you use the finalizers in various ways, they can mimic lexical scope, they can mimic resource
Right.
counting, all
But
sorts
if
of.
instead I use garbage collection, you would expect the finalizer to run when the GC has declared the thing dead.
Well, they work. I mean, the way they mimic GC is if you ran the garbage collector and it did a full sweep after every pass, then that you would get the same results as a finalizer, almost.
I'm sorry. I was trying to get the window thing. Why would that be the same? Like, if I'm
Well,
using GC, it's because I don't know what the timing of the scope exit is, or whatever. When
yeah,
the close happens.
so like, I mean, so GC, you know that if you do a GC pass and it frees something, you know that thing is no longer used.
Right.
Finalizer will free it at that time that the GC would or before?
Well, okay, so I'm trying to separate out the actions that decide that you're dead now and the finalizer should run versus the finalizer, when he runs, he does whatever he does. And the GC is one way to decide that you're dead now, and lexical scoping is another way to decide you're dead now, and reference counting might be yet another way to decide that you're dead now. Once the decision you're dead is done, then you do the close action, which might be free memory, and it might close file handles and such.
Right, and but it's all one compiler pass, and it uses, you know, a lot of techniques to, and so like there's a single predicate, which is it still being used, and then it uses techniques to decide that predicate and compute it in an efficient way. So,
but they require different
Yeah,
data
it's not a
structures,
compiler
different techniques to do it all at
pass.
once. Maybe it's doable all at once.
Well, I don't think it's not a compiler pass. The compiler will do the lexical scope analysis, but the point of reference counting is when lexical scoping fails, you can now do a runtime test, which is, for instance, reference counting, not a compile time test, and that's when the exit happens. And I can arbitrarily arrange that the exit happens at different points in your program by arranging if the reference counts are screwing around. And then I decrement them on this path or that path in arbitrary orders. And so the delete point from run to run to run varies. And then same for GC, of course, is that now it really is obviously more random where the delete happens. And of course, the other thing with GC is that the GC thread has decided that you're dead now. So he wants to run your finalizer code. What thread is running the finalizer code? It's not the thread that allocated it. Or the thread that allocated it took an arbitrary stop point and ran some finalizer code, and then it started up again. Finalizer code did a side effect in the same thread's memory. And so at a random point in time, some bit gets flipped because the finalizer flips it. So just saying, you can arrange, and Java went through this pain already, arbitrary bad shit to happen because finalizers.
My assumption was that Java sort of went through its full GC and built the whole list of things to be freed, and then started executing finalizers.
Arcane sweep?
And whatever
Close.
side effects they called were going to get caught by the next GC after that.
Yeah, it's not mark and sweep, Tito, he's referring to. It's that it can't run any finalizers until after it's run the GC. Because the finalizers may have side effects that undo GC stuff.
I'm talking about that too. No, I'm just talking about even within a thread who allocated something, the finalizer, if he runs on that thread, he runs at an arbitrary point in the future. So a thread mutates his own state pseudo-randomly according to when the finalizer runs. So yes, the finalizer might bring something alive, but he might just set a random variable to a random value that is outside the scope of what the compiler believes is possible otherwise, because it's a random point in time that the finalizer gets executed. So that's one of the issues with finalizers. So if you declare finalizer has no side effects, then this isn't a problem because it's not mutating anything. It's closing some OS thing as a side effect. And so some stat call I have or IO stat call changes randomly, but it didn't change my memory, which the compiler cared about. But if instead I said, in addition to closing this, I set this to null and that to null and this to null, because these things are all closed, it's all done. Some guy running along in the same thread reads it and it sees it's not null. Then the finalizer injection runs. Now it's null. Then he reads it again. It's not null. It's null now. It was not null a second ago. So he gets confused and, does something he shouldn't with a null pointer. And improving that it can't flip from not null to null when you can randomly run a finalizer at any point is tough.
At least in Java code bases I've worked on, finalizers have real side effects, like go call the load balancer and pull this server out of the schedule.
Yes, finalizers can have shit going on, that complicated shit. Right. So just saying, you treat everything the finalizer touches like it's a globally shared variable, more or less, and another thread's going to run, and everything he touches gets touched at a random time by the GC. So
one of the ways we avoided some of those tar pits was on our weak reference in Ecstasy. it doesn't notify the object that it slipped out. It calls a function that you provided. So in that function, if you capture the object that the weak reference has, then then it's not weak, so it never disappears. So it's kind of a truism that it avoids the tar pit that Java has, where you can bring something back from the dead.
When the best laid plans of mice and men, or well intentions, or whatever. That was not the intention, but there was.
Oh yeah, I mean the Java stuff was brilliant, but only after it was done did we realize the bad things you could do with it. That is the risk of doing brilliant, inventive stuff.
Brilliant things in the beginning, yeah. They look really cool till somebody does something horrific with you.
And that was always my advice when I was learning Java. People were like, don't ever use finalizers. You're like, why are they there? And they're like, because you absolutely need to use finalizers. Just don't do it.
Yeah, and that's because people couldn't figure out lifetime reasonably well. In the land of C++, I just used, lexically scoped destructors, and that had a hard limit. And then Java many, many years later came up with try finally, which, did the lexically scoped structuring with much more ceremony and much more volume of, it was really obnoxious.
Yeah.
But
So how do we get our languages to let us specify when I knew a thing that I'm doing a lexically scoped thing rather than a GC thing without pain and having to annotate the world?
Do it the way C++ does it. You put the destructor logic on with the constructor. There's a destructor, and you put a thing in the local scope that's not technically like a new, but it makes a new object, but it's locally scoped, so you don't have to say new, maybe. And then it leaves when the scope leaves, and then the destructor code runs.
Yeah.
The way C++ gets around it is I have to make archetypes and be like, and this is an arc, and this is an arc, and this is an arc, and
I would much rather
automatic reference counted.
Not C++.
Oh, avoid shared pointers at all costs in C++. Use unique pointers and ownership transfer. It's a bad practice for faults coming from garbage collected languages to abuse shared pointers for memory management. This is not it is not a general fallback solution. It should be avoided generally.
Let me just simplify Matt's comment, because the words that he meant to say, he put some extra ones in there, but he was really saying avoid ... C++, period. Done.
Well, I'm afraid that there's
avoid programming. Avoid programming.
big, complicated C++ programs.
I optimized Cameron's sentence to just avoid programming. That's what you meant, right?
So what I was going to say though is Cliff did actually years ago at Azul, he did work with escape analysis that would have been good enough to build the what Aaron's been describing. He'd love to have done automatically. So I know it's possible.
Yes. I did all kind of cool shit with escape detection. I was doing runtime escape detection. Well, I doing some analysis too, but I went to detection at some point and got
in Arc. Arc is interesting because so Apple used Arc in Swift mainly because Swift was just a window dressing on Objective-C. But there's actually a really good technical reason for it as well. If you look at the difference between early Android and early iOS memory usage for the same app ported cleanly between the two, the iOS memory usage was half as high. And that's because GC picks up its efficiency by having a buffer, if you will, basically a time-space buffer on memory. So, and it's usually on the order of 2 or 3 times the working set where you get into the sweet spot on efficiency. So it turns out for iPhone, especially early iPhone, when the battery life sucked and the CPU sucked, it actually gave you smoother performance and much better battery life by reducing the amount of DRAM, because DRAM is actually constantly running. It has a refresh rate on the DRAM itself. So the more DRAM you have, the more power you're pulling. And this was before LPDDR. So the first real low power RAM was the LPDDR3. We're up to LPDDR5 and 6 now. But so anyway, early on, it made a big difference. So I've always thought that if we took something like what Cliff was working on with escape analysis back in the Azul days, and you combined that with some thread locality information, some escape analysis on the stack and reference counting in GC, you could have kind of a tiered approach, which is what Aaron was talking about earlier. So it's definitely more work for the implementer, but it would be pretty cool. And you could, in theory, kind of to Alan's point, you could do some analysis and come up with a pretty nice looking profile of a runtime, in terms of not going wild, but also not ever missing anything on the GC side.
So Alan, if you do this, you got yourself some funding.
Okay, that sounds good. Yeah, I don't know.
Direct approach to garbage collection.
Yeah, no, it's not garbage collection though, because like you're not marking things as garbage.
Okay, garbage collection, linear types,
Memory
automatic memory,
I
automatic
call it
memory.
resource management because that's what it is.
Okay, okay, fine.
Yeah.
I just keep thinking back to Cliff's rocket school example where you're reading the giant CSV one line at a time and thinking, how little do I want to annotate here to just be like, okay, here's my whole processing thing. And I want to annotate my read line as doesn't make a copy. And then I want my parser to deal with the same buffer that doesn't make a copy. And then when I find the thing I'm looking for, sure, I can do some kind of cast thing that's like, okay,
Yeah.
new string, the
Right.
old buffer.
And there's a 5x speed up on a large, long processing time, which is an interestingly big enough number with very
and maybe
should
just
be-
annotating a few things with like, okay, this thing is a big collection. Make sure you never copy it.
right.
This thing is an escape that we want to make sure has no copies as I'm access. Like
So
Right.
my goal
Is
is
it
to sort of
possible
have
to
that
mark-
kernel of things that we annotate so that the compiler can yell at me if I break the things that are important for my performance. And 99% of my code I just write and never think about lifetimes because that's not the hot loop. So I don't care.
Right. We
Let
don't
the
care. Yeah,
GC
right,
deal
right.
with it.
if you deal with this kind of iterative approach, would it be possible to mark some kind of, let's say, a scope that would be a stack frame and it would keep get reused, like
Right.
a typical
Exactly.
optimization to keep reuse the stack frame that you're in?
That was exactly what escape analysis was doing. That's exactly what Aaron's talking about now. It's exactly what I did in my rocket school example. At some point, I stopped and I annotated things. And what's the minimal annotation? Some of the things I did in Java code, so I didn't need compiler support out of it, was I renamed a string to an str, which was a mutable wrapper of a string-like API into a network byte buffer. And so it looked like a string and tasted like a string to most of the things you did, but it took its bytes out of a network byte buffer. And then every time I rolled the byte buffer forward, I got a new string, but once every so often, I got a new string anyhow, and that was all part and parcel of it. That avoided turning 1 byte of a network byte buffer into 2 bytes of a string that was 2 bytes coming into your memory and 2 bytes going out, 2 bytes coming into your cache and 2 bytes going out. So it was a 5x or 5-to-1 or 4-to-1 reduction in memory read-write bandwidth. And I repeated that for lines per object, per string, for this, for that. And suddenly it was a 15-to-1 reduction. And that was the 5x speed up. There were a bunch of those things, but the main issue was.
But the compiler didn't really help you that much with that.
No. I did memory data path restructuring. I kept the business logic identical, and I did memory data path, read path restructuring. And that was a thing that the standard Java API gives you as super easy and super low performant standard data path. And I made a different version of the data path, which wasn't terribly different, but it was much higher performance. Just by thinking about the problem a little differently.
Yeah.
I needed a little.
That's the piece where I really want to get APIs right such that most functions don't care whether I gave them a vector, an array, or a slice.
Yeah, right.
Like whether the thing I gave you is here's a buffer, or the thing I gave you was here is a pointer with a length into some buffer that's somewhere else.
Right.
Whether I gave you a struct or whether I gave you a thing with pointers that say, okay, here's the offsets into the big thing that, you know, if I read it off the network and the network is in some flat buffer thing that's like length of object bytes, length of object bytes, length of object bytes. There's these
Let's talk
tiny little
about it.
lengths in there, and I end up making a copy of the entire struct every time, just because the offsets aren't right, because the lengths are there.
Right.
I don't want to copy that data. I want to hand you the thing that I keep calling a struct slice because I don't have a better name for it that just points at the. And it would be nice if my functions didn't have to be rewritten, that I just pass you either a struct or a struct slice, and they don't
Oh,
care
in-
because it's thing
In
dot
C++,
field.
you have this is called span. And basically that's exactly solving the problem. You want to pass array from CIPI, maybe it's a pointer, maybe it's a C++ standard vector, or maybe it's C++ standard array. Note that all of them has just the same contiguous buffer in memory. They are just called different types. And you don't care, you just want to have one function that accepts them all. So that's exactly the stud_span solution. You accept stud_span, and stud_span is convertible, and conversion is implemented as pointer reassignment.
Span. You're saying span with an N.
Yeah.
I heard you say
SPAN.
plus spam with an M, and I was just like,
Yeah, Bjorn is constantly
That's coming in
saying
the next
crap.
standard, but
So
with-
span doesn't care whether you get past a pointer to a thing or a thing.
I have to.
yeah,
put
it can be an array which is effectively decaying to a pointer in C, or it can be standard vector,
so it's
which from the C++ standard library.
it's spannable. Is something you're passing can be interpreted as span.
I posted a link.
Hmm.
Oh,
We've talked about this in the last time. You just use a higher kind of type. So you abstract over what are you talking about?
Note that there is a slight cost. It may not matter for most languages, but there is a cost because it can be an extra indirection. It may require one extra pointer hop,
Right.
depending on what the original structure was.
And it's actually something that could be faster outside of C++, because while C++ can specialize, it doesn't necessarily know what it has to specialize for if you're linking dynamically, while something like Java could fully specialize.
Right. I'm happy to let the compiler specialize it, where I say, oh, I call this sometimes with a vector and sometimes with a slice.
Yeah.
So I want to generate two different functions with two different kinds of code.
Yeah.
What I don't want is that I have to write that
Yeah.
code twice,
Right.
which is what I see in a lot of Rust code is you see the function that takes a t, and you see the exact same function, but takes a pointer to t. And you've got the function that returns that panics
for the
if it's got an
win.
error, and you've got the function that returns a result if it's got an error. And you're like, why do I need the result version and the panic version and the pointer version and the not pointer version? And I've got now 4 different versions of the exact same function. Those seems like things that even if the compiler needs to generate 4 functions for me, and it's doing its specialization, there should be one code block that just becomes 4 functions when it is realized that it is called in 4 different ways.
Yes.
Higher
that's
kind
a,
of
that's
types.
a jet for the win. What do you got here? Oh, Matt's putting in more things. Put them in the Google Docs, Matt. What do we got here?
I'm
Oh,
hoping
read
something
between
like AA
types.
that's really doing type analysis can figure that out. That
Oh,
if I
me too.
pass you a T or I pass you a pointer to a T, I don't
Right.
have to rewrite my function, do I?
No, I would put a one line or less wrapper that just, took the pointerness off and called the T version.
There's of course one cost that you're going to pay for this semantically. So all of those types, there is a span type for basically buffers, contiguous buffers. There's also string ref type, which allows you to have one function that's going to accept either C string, which is basically a pointer to character, or again C++ standard string. Again, you want to, the same, very similar problem. You want to have one function handling strings. You don't care what is the original type that string for. And that problem is solved. You only write one function and you have access to the string methods too. So even if you had original C string, now you can call on this starts with or ends with to skip the white space, for example. So this is very nice. One cost you pay for this in C++, though, notice that those types have one thing in common. They are reference types, because that's kind of the point. This span, you don't want to copy those hundreds of gigabytes that the buffer may contain. You just wanted to copy the pointer. But now you have a type that is hiding the pointer. So this is a reference type, one way or another. And if you return this type and the buffer has gone out of scope, then now you have a denting reference. So at least in languages without memory management, automatic memory management, you are going to reinvent, so to speak, or run into the same category of problems you would with references.
Right.
I wonder if that's why Rust doesn't use this as a pervasive solution. I don't know actually, but they would have to track the ownership somehow because they would also have to implement this as reference types. So maybe that's why it's not widespread.
Yeah, I keep having this fantasy that I can do at least as good a memory management tracking and type system that I haven't actually implemented, so I don't know. I would love to believe that.
I mean, the pattern I usually see is that things work well until you hit this little tipping point.
Yeah.
And then suddenly you have to put a lifetime on everything.
Yeah,
because you're like, oh, it can't figure out this lifetime, so I have to annotate it. But that means I need to know the lifetime, which means it's got to come from a thing that's got a name for the lifetime, which means that one needs a name for a lifetime, which means I need to get it from the next one, which has a name for lifetime. And suddenly, six layers of your call stack all got a lifetime annotation because the thing at the bottom needed a name for a lifetime of a thing that was way up there.
Interesting. Okay. All right, that was not what I was expecting you to hit to. It's all fine. The obvious one for me was simply, these things are all good until you get something that doesn't fit your toy examples you've been targeting all along. And then here's an obvious use case that's perfectly reasonable, but it's not the toy examples I've been dealing with. And oops, I didn't handle this. Suck.
I mean, once there's a FFI for AA and a runtime, then we'll start writing a standard library and see
and
what we can't write.
Shit will hit the fan quick. Yeah,
I mean, that's why one of my standard questions when someone's like, this is my toy language is great. Can you send an HTTP request?
Yeah, right. Yes.
You have to get a lot right to be able to, do what curl does.
I'm going to start with a simpler first cut, see if I can get a CSV file reader out of either of these two guys.
When it's ready, the CCC members will implement some structure in a
I'll take you up on that at some future date.
Okay, reserve it.
Not there yet, though. No worries.
What do you mean? Potential rewrite carrying 3-day weekend comfortably?
Potentially, each member of the CCC writes some structure for AA.
Yeah, Theodore's volunteering your time.
I just referring to a comment about Carol. There was this famous comment on the Orange side that someone said they could rewrite Carol in 3-day weekend.
Oh,
wait, say that again?
There was a famous comment on the Orange side. I'm referring to the so-called Hacker News when someone claimed they could rewrite curl in a 3-day weekend.
Oh, curl.
curl.
A 3-day weekend?
Clearly underestimating what curl is capable of doing.
Well, we keep underestimating things.
How well they
curl is fucking crazy complex.
You can't read the man page in 3 days.
What?
Plus, there's funny things.
The curl man page is hundreds of pages.
Yeah, that's what I'm saying. You can't read the man page in 3 days.
So there's actually a brilliant Okay, so we just went through this a couple months ago as we wrote a tiny fraction of curl in Ecstasy. There's actually a brilliant implementation in Java. Some fucking
Wait, you're praising Java curl networking?
Holy shit! What? No, some guy ported like a big chunk of curl into Java, and it is insane. Like the complexity.
Fine. Wow. Okay.
Gene went through it, so you should ask him for the link.
Oh, here's I could rewrite curl. You should put that in the Google Docs too, so we can all have it in all our for a lifetime reading. I could rewrite curl in less than 100 lines. I can do it in a 3-day weekend.
I mean, there's things that are deceptive.
Curl exploit. Wait, what?
HTTP Google.com, HTTPS Google.com. It's only one letter change. How much more bad could it have gotten?
How much trouble?
And HTTP is not a spec. That's the other thing that people don't understand until they've implemented every corner of it. It's like 500 different specs, all designed to be explicitly incompatible with each other, but in random tiny ways.
Yes.
HTTP 3 is a little better on that particular metric.
HTTP 2 and 3 are both dramatically better than 1, but they still carry along a lot of bad junk because they have no choice, right?
CSV is the small brother of the same problem. There are 100 specs, but not 500, but 100 specs for CSV, all different.
The one that I find really painful there is that Excel CSV doesn't match the IETF CSV.
Yeah.
So the crazy thing with Excel is that you can do a CSV from Excel and you're looking at it and you're like, oh, this isn't that bad. And then you give it back to Excel and say, here, import this as a spreadsheet. And it's like, and it dies on it can't read its own export. I actually had this happen recently with a project we were working on for a company that gave us a Excel spreadsheet, and like Excel would not read in. After you took that spreadsheet, exported it, it couldn't re-import it.
Yeah, wasn't a bijection. It wasn't even a bijection. It was just crap.
There is something even better about Excel. You have run into this if you have lived in Europe. So Excel's definition of CSV is actually dependent on your geographic region. So if your locale is set to a European region like Danish, it's actually going to be a semicolon separated file, because colons are used for decimal point separators. So depending on where you load or save CSV, Excel is going to have different definition of what CSV is.
Yeah, it shows CSV reader starts by reading a few megabytes of your CSV file and doing all kinds of heuristics and counting and analyzing. And he almost always gets it perfect in one, but he does, like I said, he reads several megabytes and he does a bunch of analysis to decide what is the common thing that looks like a field in, scope in, field header, quote, misquote, double quote matching, blah, 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 all these things, line ins. And then he says, okay, I think you're this. And then he reads the file that way. And you can override all those if you want to, but you just take the defaults. He does a good job, but it was non-trivial, as Matt says. It's just everybody did it different.
My favorite was we ran across a test suite somewhere that was called CSV Acid. And they distributed the tests in a CSV file. So the first column of the CSV file was the name of the test, and the second column of the CSV file was the CSV file.
In line, in one column.
Because if you put it in quotes, then you can have commas in there. It's just that all of the quotes now become escape quote.
Yes, assuming that they properly escape quoted themselves. One of my first,
looking at this CSV where all of the things in the second column were themselves CSV files, if my mind was just like, okay. Did you get the escaping exactly right?
My first, well, I taught a class at Stanford one semester in data science, and the first thing we did is going to read the well-known example starting test file for the set of survivors from the Titanic and do some data science on the set of survivors from the Titanic. And that CSV file was handmade back in whatever the Titanic sank, 30s or something, and it carried along for years. And it has mismatched quotes, single quotes as people's names. It has columns which are all integer for ages except for an infant who has 11/12 as a fraction. And he has spaces in names, and he has embedded spaces for column separators. He has like 3 different column separators and different things for, like digits and names. And there's a bunch of things in there. It's an example of a really bad CSV, fails all modern specs for what a CSV looks like, and you have to eat it. So all your CSV parsing, like, half the people in the audience were like, I'm going to use Python, use CSV reader, okay. Half the people like, I'm a mathematician, when use like MATLAB, and they died like a pig. Half the people were like Java programmers. I'm just going to write a CSV. It's going to be like fucking read line string split, and they're like dead too. So anyhow, that was yes, broken CSV from the 30s.
The fun one that blew up on me, I was doing something that worked with the IMDb data set.
Yes.
And the star ratings are normalized. So rather than being the numbers 1 through 10, it's 0.1 through 1.
0.10. Yeah, wait, fine.
So it's running through this big batch script, and it gets almost to the end of the alphabet, and it's like on the S's, and suddenly it explodes.
And
it turns out that every movie in the IMDb database is ranked on a scale from 1 to 10. Except for one of them.
What?
Would you like to guess what movie in the S's is not ranked from 1 to 10?
Goes up to 11.
Spinal Tap goes to 11.
Oh, jeez.
So the fraction is in 11ths. So it's got whatever 8 11ths as its star rating instead of 0.8. And it blew up because it wasn't one of the numbers that I was expecting, because the loop had assumed it was going to be exactly 0.1, 0.2, 0.3.
Yeah, right. Exactly. Oh, yeah, totally. Yes.
But turns out that there's exactly one that goes to 11.
All
Everything
right,
else is out
fine.
of 10.
Yeah, I mean, all these things. I read a Wikipedia 30 gig Wikipedia word count, and I was doing how fast can I do word count on 30 gigs. And what's the longest word in that Wikipedia of like 10 years ago? Well, it was the letters for penis repeated several hundreds of times, several thousands of characters long as a single word. And that blew up some assumption I had somewhere about how big a single string is. And then can I slip this by the editors? Oh, look at this. In fact, I can.
Fine.
All right, done. Anything else?
Okay, so I want to go back to the pets example.
Okay, fine.
I'm just wondering, so you wrote this example, like, what are you expecting it to do besides crash? Like, if it ran, like, what would you expect it to do?
Oh, hang on. Let me share the screen, bring it up. What I expect it to do is here's the example. What I expect it to do is print some random count of pets, some random number of pets, and not crash. Either there's a compile error because I didn't memory manage it correctly, or for instance, reference counting or GC's running, and that's all fine, and it just works, and it prints some pets. As far as I can tell, I wrote a valid program, modulo, syntax errors, and random being both a function and a generator or whatever. This should work.
So, like, when do you expect the first pet that's to be deallocated, I guess?
Randomly, depending on how the random number generator works, the first deallocation happens in the first loop.
Okay.
Random says, I picked a number 500, I made a pet. Sometime later in the first loop, he picks 500 again. He overwrites that pet with another pet, and you delete the first pet. And because I've done 1,000,000 out of 1,000 due to the birthday paradox, I almost surely stomp some pets in the first loop.
Okay, so I wrote, these conditions and where it frees.
Yeah, I'm going to scroll down to the second body here. Yeah. Yes. And you said something like, if not exist, I, which is essentially garbage collection goes and counts and says there aren't any.
Right.
But that's not efficient to do it every iteration of the 1,000,000 times through the loop.
Right. And so I guess my question is, did you expect it to be fast?
Yes, to have a programming language that's usable, it has to have a reasonable speed cost model for any particular use case that it's coming around. Or I just program a different language because this one's too slow.
Well, yeah, and specifically, it can't have an execution model that degrades like this would.
Yes.
Right. I have an array of 10, it doesn't seem slow. I have an array of 100, something's weird. I have an array of 10,000. Holy fuck. This is slower than my TI calculator.
In favor of Stroscot, how about an analysis that when you reach to the 500 and sees that there is a pet there, just reuse the memory because it's the same object. It has the same layout.
Here's the question is, how do you know that pet's reference isn't shared? Because of the other part of the first loop is some of those pet references are shared. I'm doing references, not inline value objects. I'm specifically forcing random sharing patterns and random delete patterns.
Somewhere in here, pet 5 pets.
On the second, the screen's showing on the second.
Okay.
Yeah.
So here you hold a reference to the 500 pets.
Pet number 500, whatever. There is some reference to pets at 500. I pick that up where I say pets of rands 2. I pick that up and I store it down somewhere else. So some pet might be both in slot 500 and slot 750. The same pet. So this is a non-trivial. I can't just say because I've stomped, I automatically kill a pet or a no. That is not the case here. On purpose, there is no analysis, no sensible analysis you can do to discover it's sharing or not. You are limited to things like garbage collection, reference counting, arena, structured lifetimes, throw an error.
That was my
Steve,
thought.
what are you going
A
to do
sensible
this for
analysis
this?
might
Okay, one at a
Sorry,
time.
go ahead, go ahead.
a sensible analysis might be able to look at this code and say, I'm pretty sure there's not going to be any cycles. I can reference count it.
Yeah, that's a fine answer. But I wanted to hear Alan say what his thinking is on how he's going to solve this problem.
Yeah, because there is one way to solve it that is actually probably the fastest way. And so what it is that you store each new pet not only in this pets array, but like just in an array list. So like, you know, you say, you know, I don't know, list. And then you push the pet to the list whenever you create a new pet.
Whenever you make a new pet, as opposed to
Yeah.
the new pets all come from an arena, and if you make a list of the news, you've got an arena, basically, of the new pets, and that's a fine answer. Then the arena goes out of scope, all the pets are dead, and you're done, because you've done lifetime analysis for the whole set of 3 loops. And that's a fine answer. You've said I've made an arena. Now you have to do escape analysis, you have to do something when somebody does escape, you have to a bunch of things you do with arenas, but arena is an interesting answer.
Yeah. And so like, I mean, the thing for the arena is you'd have to write the list explicitly. It doesn't automatically do it.
No, the new pet internally goes to the arena and says, please, Mr. Arena, bump pointer me. Well, the arena just did it right there. That counted in the arena. It's on your list. And at some later date, I could walk the arena, same as garbage collection is going to walk the memory and ask an is a question, what are you? What are you? Because I have a mark header, I have a header class, so I can tell what's a internal nested pointer or not. And basically arena is just a mini heap that I could garbage collect, or I could toss all at once, or whatever I'm going to do.
Steve, what are you doing in AA? Arenas or GC for this example?
Oh, for AA, the theory is I'm going to make you pick your memory management on a lexically scoped basis, and the default one at the top of the universal will be garbage collection. If you don't say anything, you'll get a garbage collection. But you could say I want to do an arena here, and then I haven't figured out how the hell I'm going to do that analysis, but I think I can. So I have a theory that says I'll let you pick arena if you want, and if you don't, you get garbage collection.
All right, fair enough.
So at the beginning of the function, I would just say new arena, and then when I was making the new pets, rather than saying new pet, I would say arena.new pet.
Yeah, there's something you have to do.
And when the arena itself went out of scope,
yeah,
everything that was allocated from the arena went out of scope.
Yeah, that was pretty much similar to my question. I was actually wondering, but this is almost the same question. What are you going to do with the assignment? Like pets round equals new pet, but you could change the assignment to something like construct with arena or whatever, and that would be perfect.
Well, the theory on assignment is I want it to be a single pointer store modulo rough counting games. But if there's arenas involved, then I have to do whatever.
You can't mix and match. I mean, that's the thing. You can't mix. You either disallow at compile time anything that would allow something from one arena to point to something in a different arena, etc., or you have to check on every assignment.
Yes. So that's a store barrier in the land of Java for generations. You get a check on every assignment. That's a store barrier. It's a made very cheap check. Or you do compiler analysis in the land of stack-based allocation and Azul that Cameron was talking about earlier. Those stores did a range check, which typically didn't fail, but the check had to be done. And the range check was, I took this pointer, I took that pointer, and I shifted some bits and I XOR'd them, and they had to be 0. So it was a fairly cheap check, but there was a check. And if you failed the check, then I immediately ran and did more expensive checking.
That's just something you may be able to do at compile time if you don't make your arenas too fancy.
Yeah. There's a theory that says with annotations from the user and a little compile time logic, I can either always do it for free or fail the compile time, and then the user knows they're getting a runtime check. And then they ask for the runtime check. And they ask for their lexically scoping. In here, if I have an escape, I know I'm going to have some, it's okay to escape this arena, and I will silently insert the runtime check. Or you said I have a perfect allocation in this region, for the scope. And then if I can't prove it, I'll point out, and here I can't tell if you're escaping or not. So do something different.
So if I return an object that was allocated by an arena,
Yeah.
but the arena is going out of scope at the end of that function,
Yeah.
that's simply an error, and I'm going to get a, what you should be returning is thing that was allocated in the arena dot clone or whatever.
It goes right. It goes to the how do you want to handle it? In the land of SBA, stack-based allocation, I knew that you were changing stack frames, changing arenas, and I had to move you from one arena to another, and I had to copy it. And I didn't want to do that very often. So separately, I did counting games behind your back. And next time you made that object, I put it in the up scope arena. If you have non-stack based arenas, I would probably throw an error at you and say, name the arena this is getting moved to. You can't, you're escaping. Where do you want to escape it to? You got to tell me. And that requires you to take a second arena in as an argument somehow that shows up. And then you said, oh, I'm escaping it from the current arena, which you're going to scope into this other arena.
You could totally imagine taking 2 or 3 arenas as function arguments.
I think, you know, I know in the land of C++, I totally took arenas as arguments. That was, you know, a thing that happened.
Yeah, it's nice to not have that sort of weirdly baked into the language that
yes,
arenas are just objects that you take as
they're
arguments.
another
It's not
right.
like...
They're an allocator in the land of C++, an allocation thingy, which I don't care how it works under its hood. It might do garbage collection internally. It might do reference counting internally. But I have an arena thingy. I have an allocation thingy that I want to allocate into and let that allocator manage his space.
I wonder if that's a good enough reason for AA to not have a new keyword and just have sys.new.
Yeah,
and sys.new is the global allocator.
There's some allocator that you can go get your hands on and then start calling new on it or something. I haven't sorted that out yet. So that's all.
And if I give you a sys.new that returns errors and doesn't actually allocate things for you, sorry, you don't get to new stuff function.
Right now, I don't have that. So this is all future random guessing talk. I don't want to go too far down the path. I claim there's some interesting thing to be done there, but I haven't done it. So it's cool to talk about, but it's all like made up stuff. So maybe it works and maybe it fails miserably. We find out 10 years later. But that would actually be a big win for AA. If it was being used by enough folks that 10 years later we discover the code smell of.
The example here with the for and new, is this valid syntax for your language, Alan?
Oh, is what? Which one?
Are these examples actually valid your language?
Yeah. I mean, they're not like the raw syntax, but I was thinking like some macros and stuff that probably look reasonable.
So it's not too far off.
Yeah. Because like I don't have loops in my language. I just have recursion. So, you know, everything that looks like a loop, you have to rewrite it as recursion. And you could do that with a macro, but
I'd say you should give the macro in because that's what I'm doing in AA at least. I have the easy, it looks like a for loop, it smells like a for loop. Under the hood, it's just you know, recursion, fine, whatever. And then the optimizer turns it into a loop because that's easy. But fine. I might yet have for loops for real, but I don't at the moment. All right. Anything else?
Oh yeah. So Aaron made this comment that my type system can't prove things. So I wanted to ask what he meant.
Well, you said I don't have types, and then you said I do, and then I have only sets, and immediately as soon as you have only sets, there are some things you can't prove. No, where'd your sets go?
Sets, yeah.
Somewhere around in here, Aaron said something.
Yeah. So like, I mean, you define, you know, the predicate x p of x, and so you can write whatever you want as a predicate. Like there's not any restriction on the set. So I don't.
What's the set of sets that don't contain them?
So is my predicate allowed to be like function f halts?
Yeah.
Yeah. I mean, I'm not sure I'll have like a halt function, but the compiler will. So probably you could just, you know, use the compiler's halt predicate and say, is it halting?
Okay, and then the answer is you can't you can't type the program. Well, this was the answer. You can't.
Well,
type
the answer is it
until-
can prove it. If it can look at that function and go, yep, this is within exponential time, then fine. And if it can't prove that it's within exponential time, your compile fails.
Well, you asked for halting versus exponential, but there's a version that says it takes me more than 15 minutes. He had this timer in there too. He had 15 minutes, and then I'll just quit and say, no, I can't prove. Which changes his language semantics according to the speed of the machine he's running on. I ran this on a bad Amazon container slice of an X1 machine, and it was super beaten down. So it failed to compile.
Yeah, runs in less than 15 minutes seems like that's better as a runtime check than a compile time check.
Yeah, right. And then if you say it has to be a compile time check, then yeah, the halting problem, and you can't do it.
Oh, so like if you go to the end, was like a thing on the build system. I never got to that because it's an extra slide. It's like no, yeah.
Well,
Yeah, tooling was so that one.
we want to see modules too.
We have a custom build system, and so the plan is to make the compiler integrated with it so that it like saves all the build results. So once it proves a theorem, like you don't have to keep rerunning it.
Yeah, but I'll hand you a theorem that you can't prove in the lifetime of the universe.
Well, why did you write such a terrible program?
Because I want to break you. What do you
Because
think
he
I
wants
wrote
to
it for?
mess with you, yeah.
I want you to come along and, say something reasonable. I give up now or something.
What was the module slide?
Oh, the modules? Yeah, I don't know. I don't really, I mean, the reason I put them at the end was because I don't really have much to say about them.
Yeah, fine.
Okay.
So,
You can bet when I declare I've got AA done, there will be people who will be tempting every possible broken thing on the planet just to see how it breaks. I know that's coming.
I do think we've under-discussed module.
Oh, in
I
general.
feel like most of these language module is basically just function because it's a scope. Like, why do you need anything other than a closure for a module?
And then you need external exposure to tools that want to take modules from other users and have you manage.
And it's like,
them.
yeah,
Maybe
what actually makes a module special?
Yeah.
It seems obvious to me that module is like a subclass of closure.
Yeah, right.
But it's not clear to me what extra restrictions you want on module boundaries that you don't necessarily want on function boundaries.
Yeah.
yeah, I mean, so there are
acceptable name.
Like there's like 1ML and mixml and like a few other papers on the ML module system and extensions thereof. And like I read them and I was like, okay, they're all type systems. I don't care about type systems. So this is what I got.
Well, I'll claim that the JavaScript module system sucks. So there is a counterexample.
Yeah,
well,
JavaScript was almost easier back in the days when the module system was call eval on something.
Yes, there were no modules. And then there was some spec, and then there was another spec, and then there was another spec.
So
which spec are you doing?
So what sucks about it though? What do you need that you don't have, and what does it have that you don't need?
3 incompatible specs. Also, things that are modules get evaled in, so you can't always tell what modules you're calling at the start. But 3 incompatible specs. Let's start with that one. Somebody made up a thing that he could treat as modules using exactly function closures like Aaron's talking about. And
yeah, I kind of like the require pattern.
They had to. That was the only thing. And then somebody else said, oh, let's be official and put some syntax in. And then like the European Committee for JavaScript, or whatever the hell that thing is, said, oh, let's be official again. And just like the XKCD, now there are 14 compatible specs or whatever, incompatible specs for modules.
So I'm just curious. So Cliff, I'll ask you first since you're talking right now. What do you want from a module?
I want to eat my lunch at a reasonable hour.
Okay, that's a good module.
Well, I mean, I want to have a spec that's sensible. I don't know what I want, honestly. That there is a thing that says I want to have an easy import to bring somebody else's module in. I want to have a fairly well-defined, easy export that says these things taken as a whole, declared as a module, as an artifact that I as a person am managing. And that's my export of the module somehow. And then there's I want to go to some set of repositories, you know, Maven, Sonatype, Cough, I don't know what, where somebody else can grab my module and use it fairly readily. And that means there has to be some spec on what it means. We all agree on what is exported and imported out of the module. There's a versioning system involved. There's a naming system that's compatible across the universe for modules. So I can't have, you know, $ backslashes in my name because Maven hates me, or less than greater than because the XML hint causes Maven to blow up. I don't care what. So there's some naming conventions on the modules. There's a versioning spec on modules. There's the imports and export list on modules. There's a typing on those imports and exports.
Typing?
And that's a very shallow discussion. That's the part is about as far as I go at the moment. Somebody else's turn.
Aaron.
Yeah, so I'm going to echo all of Cliff's. I want modules to have an identity. I want them to be versionable, so I can say, go find me if my modules are out of date. The second thing is I want some kind of import statement that lets me import from several different places and not necessarily run the eval 12 times. So if I have 12 functions that all import the same module, it should run the eval once. It should stick it in the modules cache.
Yeah,
and the
cache.
Next thing that imports that module should just get handed the module, not reread the file, reevaluate the file, make another
So
instance.
you're talking
closure.
specifically JavaScript style eval module stuff. What if
Yeah.
what if it were outside of a JavaScript style? What if it were, say, a Java style language
Yeah, Java
where things
style
are
is the other
compiled?
obvious flavor. You still want a module cache.
Yeah, I still want to be able to import the same module from lots of places without necessarily creating a bunch of instances of the module.
Yeah.
Reasonable. What else?
And the last one is I would like the ability, I know it is going to cause some pain inevitably, but I would like the ability to do cyclic imports.
Yeah.
That I can, in theory, be like, here is the mother module. It imports a bunch of the kids so that everything gets pulled in. But also the kids may talk to each other, so they need parent ... whatever.
I love your answer, and I love Cliff's answer, which is proof to me that neither of you works in ML. So, Alan, what should a module do that they completely? What should a module do that they completely missed?
Oh, by the way, well, I think you should be able to do cyclic imports. You should advise people not to.
Oh, well, I did figure out the semantics for cyclic imports. No,
but I'm asking for requirements. What should modules be able to do that they haven't already described?
Let me look. Well, let's see. There's a lot of import syntax.
You got a slide you want to share?
Because we'd let you describe how you resolve cyclical imports, but we'll have to cut you off after 15 minutes.
Oh, and then like they have to integrate with a package system. And so like I should be able to publish a module as a package, just like one.
I'm sorry, you misspelled package as module.
Yes. And I don't know. Oh, there's the question, how do you access definitions that aren't exported? And so the answer is you have an internal submodule. And so you just import the internal submodule of the module. And then you can access everything that's defined in the module, including the stuff that isn't exported.
Isn't that a giant security hole?
No, because you're just writing code. It's not, I mean, like there isn't
that's all every hackers ever do is just write code.
So like, I mean, think about it. Like the reason they didn't export something is not because they were worried about security. It's because they didn't think anybody would use it.
Wait. They didn't export my password because of security. They didn't export it because they didn't think a hacker would want to use my password.
No, like if you want, I mean, like think about it. If you have source code that contains a password on like GitHub or something, that's the security hole. Is that the security?
No. It's okay if it's on GitHub. It's just bad if you can access it from a different module.
Yes. If the Allen module can access the Cliff module passwords, I'm unhappy.
No. See, that's not it at all. Because like the developer, if they want to know the passwords, they just open up the source code for
The
the clip.
developer already has access. The hacker went to GitHub and said, please, Mr. GitHub, give me the Allen password. Oh shit, he's got no money. Give me the Cliff password. I got no money either.
So no, you better have $100. You know,
I got 100. I got 100 to spare. Hardly worth the time for the hacker.
No, but like, I mean, the thing is that if the programmer like wants the internals of the module, they can just copy paste the code into a new module and make them public. So like it's to avoid copy pasting. You just say, oh, you can import the internals.
Okay, so there's maybe separate things going on here. I have a module, it has secret bank account numbers it holds on to during its normal execution. The source code to the module is available for public consumption on GitHub, but that source code has no passwords because it's not running anything. I'm okay with you grabbing the source code because I put it in the public domain. I'm not okay with random module I sucked in over the internet and I'm trying to have it do something it claims it's going to cause me dancing babies or whatever. And it secretly under the hood asks for my module with the password. Oh, that didn't work. So I want the inner module with password. Now I have your password. I'll go get the bank account while you're watching the
You're
baby.
tempting Matt to go off mute at this point, you realize.
Oh,
But this is the whole C++ security thing, which is it's just bullshit. Like you can't take a language that allows it to talk to compiled code and be like, I want to add security to this. No, you can't do that. It's fucking impossible.
right.
Anyone who claimed, it's like people who think that public, private, protected in C++ is a security feature, just, fire them and get
Isn't
around.
it true about most programming languages, including Java? Because you have reflection in Java, which you is to bypass this.
Matt is totally correct.
I remember that every single C++ book, I mean, it's not even stated anymore, but in the 90s, it was very explicitly stated this is not a security feature, right from the moment public and private was introduced. There was never an assumption that was going to work for security.
Yeah, and I can tell you, most of the C++ programmers I had the joy of working with never read that book.
That sounds terrifying. I mean, Stroscot book also says that, I mean, which probably also isn't widely read. Looking at some code that was written in the 1990s, but that's another matter.
Yeah. So, but
I mean, you can write an object capability language.
I think only WebAssembly is attempting to address this seriously.
Yeah, we did.
Yeah.
In Ecstasy, that's what the whole design is for. Like,
and I claim I'm doing this something similar to AA because for the same exact reason. You shall not be able to get at something simply because you have the top level reference.
Right. Because Cliff's question and Aaron's earlier thing about eval, I mean, they both kind of highlight the same problem, which is if you are running in ring X, whatever X is, ring 0, ring 3, whatever, is some process space, some memory domain, whatever the fuck it is, right? You're running there and you bring something else into your domain, game's over. Game is over. Yeah. Like if you can bring code into your domain, you have zero security, zero. So do not ever, ever, ever bring code into your domain, period. End of story. Now you have security. Like how hard is
I can bring source code into my domain.
That's not code.
Yeah, you brought in a string with source code, the string. Now the string goes through the compiler who makes every verification necessary. And he makes code that is acceptable to your security model, not you brought code in. That's an okay thing. Because the compiler still gives you the security. No, if my compiler has reflection, then I shot myself because I got reflection going on. But if the compiler just goes through and says, I'm going to let you do everything that you could otherwise normally do if you've written the code here, then I have that much.
It's not Java or C++, both of which compilers are Turing complete, right?
Yeah. No, the C++ is a different one because I can just cast to a byte pointer and go surf your memory. So you have to start with.
But you're talking about running code there. I'm talking about actually giving it source code and having the compiler have side effects as a result.
Oh.
That's the Scala has this. Stop. Scala had this, and it has to two-step. It has to first compile the string to a code, and then you can use the AST in your code. So it has to be compiled as a separate thing. So
Yeah, but the compiler is
state.
supposed to give you the security
Yeah,
of
okay.
your domain. The
That-
whatever domain, whatever security I want to get out of this wad of string I got. I got a string wad.
But
I'm
if you
gonna
bring
execute.
this, if you bring this in your library, that has also mandated to have your compiler as a library inside your program.
Yeah, so what
That's
Tito was
about.
telling you and what I was saying about Java and C++. So Scala, Java, C++, you must not bring a string in and compile it, because doing so allows code to be run on your computer that you did not, just compiling allows
Oh,
code to be
not
run on your
Java.
computer. Yeah, Java's compiler with generics is Turing complete, so you can have.
But Turing complete doesn't mean you can access outside the sandbox of the compiler.
No, but it can take your CPU forever.
Yeah, he can burn CPU indefinitely. Yes.
Which is a bad thing.
No, I agree. I agree. And you could verify that one with a timer. I'm going to let this thing do something with a timer.
And
on
I
it.
haven't checked with the team there, so maybe they fixed it, or timed it out or something.
No. I remember the Java C generics went to Turing complete. There's a paper on that.
Right.
Some stupid thing.
But they probably put some fix in for that by now. Fingers
Nice.
crossed.
I
Anyway,
don't know. Right.
so-
right.
Yeah, so the model that we did is like, you want to bring code in, that's fine. You bring it in by creating a type system, creating a container with a new
Yeah.
type system. You can't bring it into your container. You can host a container under your container,
Right.
but
I'm
that's
with you in the same mode as AA in that sense. You don't get, the guy who gets compiled can't see anything but what I let him see, which is what you just said as I bring him into the container. I give him visibility in some set of things, but I have to give explicit what I'm giving away, and anything else he can't get.
And so the idea behind that was, since you're creating a new universe, anytime you want to bring code in, it better be damn cheap to create a universe.
Yes, and I haven't sorted my head on that one yet for AA. That's a different problem. All right, once again, I'm going to claim this was very interesting at the end here. We should revisit this whole discussion one more time.
No, I
we're-
love this discussion, but it just means we have the wrong people on the call, because you guys all
Haven't-
agreed. You
We
guys
haven't
all
finished
agreed with me.
modules. We haven't
Yes, we
finished
haven't finished
modules.
We're not. The
I wanted to
15
ask
is up.
modules as first. I wanted to add modules as first class values. You should be
I'm-
able to pass the module. You should be able to select an if statement of the module. Maybe you want to use one hash table or one on file system,
Yeah.
depending on the
Yes.
implementation.
Yes,
we
that's
are
it.
It should be a
running on.
subclass of closure.
Right.
Anything you could do with a closure, you should be able
But
to
see,
do with
that's
a
what I
module.
want. That's what I was hoping you would go into, Aaron, because that's the part I don't fully
Okay.
grok yet.
I'm moderating
Next
2.5 hours so that we're not here.
So
until
let's just go
people
for
die.
one more hour and see if Cliff starves to death.
Yes. Now, mind you, I could lose some weight, so that's not a terrible thing. All right, until next time.
Talk to you soon.
Okay,
Bye.
guys.
All
Thank
right.
you all.